Right? Because this one has sine and omega. Okay, by allowing the solution in this form, omega n t, we can express this solution. We can use this form to express any form of this solution, right? Because this is complex, meaning that in complex domain, this is A, this is omega t. So, A, this is the cosine omega t, and this is sine omega t. Okay, depending on the phase we are putting, for example, over here, then we can express how much sine term and how much cosine term we will have. Okay? So, what we do using this, if we plot this one over here in this equation, then we have omega square minus k. Okay, A is equal to, let's begin with omega over here. Has to be 0. Right? Right? Put this one over here. Okay? Then I have minus omega square m plus k times A equals 0, right? Okay? Then the solution of this equation is, one solution is A equals 0, or minus omega square m plus k equals 0. Okay? This is trivial solution. And this means that the omega square has to be k over m, and it turns out to be natural frequency. Therefore, the solution is xt is equal to a exponential j omega n t. Right? And imposing the initial condition, okay, we can determine the real value of A, imaginary value of A, or we can determine the phase angle. Okay, that's what you did. Now, let's see what happened for 2 degree of freedom system. Okay, similarly, in this case, let's try x vector, that is x1 and x2 is equal to some vector exponential j omega t. In other words, I have u1 and u2 exponential j omega t. Okay? I'm doing same process. Then what I have is, okay, in matrix form, minus omega square m plus k and u vector is equal to 0. Okay? I'm emphasizing again, I'm following exactly what I did for a single degree of freedom system. Okay. Then, the solution of this equation u equals 0, or right? But then vector u equals 0 is a trivial solution again. And this is matrix. Therefore, not just the same omega square k, matrix M plus matrix K is 0. We have to say determinant of this has to be 0, because the solution of this is, to have a non-trivial solution, the inverse of this matrix has not to be exist. That is a little bit complicated concept. But in analogous with what we are saying over here, we could say the determinant of this has to be 0. Meaning that, what is the inverse of this one? The inverse of this one is what is it? Some matrix divided by the determinant of this one. If determinant is 0, the inversion does not exist. Okay? So I can say determinant is 0. And that produces us, okay?
Is that related with that vector notation?
This one? Which one?
With that.
Yeah. Because I assume that x vector is u exponential j omega t, and this means that I have to differentiate this one twice with respect to time. That give me minus j omega and j omega. J times j is minus 1. Okay? Okay. And this gives us omega 1 square and omega 2 square. Why? Physically, because this is a 2 degree of freedom system, and mathematically, because this determinant gives us 2 omega. We will see. Okay? And this we call characteristic equation. Okay. In other words, that equation characterizes the vibration of 2 degree of freedom system.